Hi, my name is Keenan Hardard. I'm a biology professor from Minnesota State University, Mankato. I study cancer research and education data research. So today we were going to do a video on symbol size and where multiple variables formats in Prism can offer you some flexibility and also how I've come to love and use these in different formats. So I've got some education data here. Students in rows. I'm actually isolating all the people that have high work commitments right now because I wanted to have a smaller group so we could kind of take a closer look. So let's say that you've got a bunch of data kind of like this, like you get to kind of choose what you want to use. You've got some categories, you've got a lot of quantitative data. So let's go ahead and go to new graph. I'm going to say, go ahead and give me once we load this up. Oh, okay, there we go. Go ahead and give me, I'm going to have this recent cohort that I want to use right here. I want to use multiple variables. Perfect. Let's say that I want to do something a little easier going. I'm just going to say, let's say, how did exam one go versus how did the overall class go? I kind of like that because it's like, all right, how predictive was that first exam? Let's start with the size going to zero, just nothing, right? Let's start single size. Let's say, all right, if you're a working student, were you one of the ones that had high attendance or low? Let's go there. So let's start with no size. Start right now. All right, there we go. So in your classic multivariable setup, you're still going to have everything that you need in terms of what you would like up here, things like that. You can customize. As you can tell, I kind of, like this setup. You got a good little color code. Everything's fine right there. Let's say that again, you're in a single size right now and you don't really want to mess with too much and you don't want a variable yet, but you do want these bigger, you can always just size them up like that. That looks fine. Okay. So right now we've got a little setup here. You can kind of see if you did attend, you had a better look versus if you didn't as much. Dang it. But let's go ahead and say, how did these people do depending on another variable, let's say? So to begin, let's say that we have let's say that we have a GPA, right? And this is a continuous up and down sort of flow. So for GPA, this means that there's going to be a bit of a scale on the size and it's going to be continuous. What I'm going to want here is you can start by saying, hey, group everybody by the smallest one and then kind of let it go up relatively. But what I actually really like to do is make sure that I control the smallest and the largest one. So see, now I have a choice here. So I can kind of mess with the size right here and say like, all right, minimum size, and it looks like the minimum GPA here was a 2.7, the highest was a 3.9. Let's say minimum size I want is a 4, and let's keep this one over at a 16, pretty big. So I'm going to apply that, and you're going to be able to tell that now I've got a little size scale here, and we can actually get a little bit more of a visual result. So I'm also gonna make my axes a little closer to each other, things like that. I always love this. So 70 to 50, that looks fine right there. So now you can add size as a variable that is continuous, kind of like this. And this does tell me quite a bit. This looks good. I mean, kind of tells a story like we've been seeing, right? So let's say that I wanted to add something different though. Let's say I don't want a continuous variable. I just want to know, let's see, I just want to know, did they attend something we called a prefect session? It was sort of like a large review session essentially. So I'm going to give the group that does the high prefects, I'm going to give them a pretty large size, like a 10. And the low prefect people, I'm going to give them a smaller size, like a 3, because I want this to be a pretty good little size differentiator. So let's go ahead and apply that. There we go. That is pretty big size difference, but I mean, it's perfect for your low and high categories, right? It's not bad. So this is another way that with a more categorical variable, you can also use size. So what I want to do next is actually try a bit of a different sort of plot setup. So I want to actually do, for my x-axis, I'm actually going to try and do financial stress or not. Let's try, I want to say, I want a category that's going to be interesting. I want to do, well, let's do let's do employment stress on the X and then see how they did in class. And I'm actually keeping my colors and everything else the same. So this is actually going to change the type of graph that we're doing. And actually, I got to make, yeah. So since these are technically Likert categories, now I've basically made like a little dot plot here, as you can tell. So again, symbol size can kind of really shine through in a fancy way like this. Now that we're sort of less in an XY thing, even though it did take this as a quantitative variable, this is technically a category of Likert, but I like when it does this, it's going to be sure that it keeps me in that Likert scale. And then the max, I want the 5, and then we don't want any ticks. So now the Likert scale looks a lot better, things like that. Oh, looks like I have to give it a bit of an edge there. Nice. So again, another way that you can use size, and let's say that we're setting this up here, I could say now if I wanted to use size as a quantitative variable, this wouldn't be a bad time to give it a shot here. So let's say average exam. And again, we can watch this where I just give it the smallest one and see what happens. So let's go ahead and take that and look right there. It kind of doesn't control it as much as I'd want. It doesn't show that spread that I kind of like. See how the setup is a little smaller, and that's okay when you want really subtle changes. I like the bigger changes. I want the smallest to largest to be really to kind of really pop on there. And then again, that's going to give you a really nice visual depending on what you're after, just looking at right here. So again, some other details that again you can always add. I love showing the borders on the little plots, things like that. That's not technically a dot plot size issue as much. Um, color and transparency is also very important, but this would be something that this is something that it took a while to master, but it's very useful. And again, if I want to say, for example, if I want to go back to something a little more average exam versus exam 3, if I want to go something to back to a little more quantitative, again, I'm going to do the final example here. So let's go ahead and apply. Let's get us back here. And then, yeah, I have to go back to my auto range again. There we go. And I do want to just kind of soup that up a little bit. Sorry, I need my ticks. There we go. And I guess I need them over here then. I hopefully didn't trouble anybody with that. All right. So I want to do size in here now. Let's actually use one of those Likert scales. So even though the Likert scale is quantitative, it's more of a category. So let's go ahead and try that one last time. All right. So now the size variable, I'm going to say, give me academic stress right here. So the least stressed people were a 2 out of the 5, but the most stressed people were a 5. And this is actually going to run relative now that I have 5 categories. So even though each person has a 1, 2, 3, or 5, and 4, now you can see their stress levels on here. So it looks like everybody was pretty academically stressed that was in this working group. So I'm actually going to give them some sort of other shot here. Let's try financial stress because this is actually one that, yeah, you see some more diversity in this one where you do have people that are still low stress, even though they are my working students, but you have a lot of 5s out there. See that? And again, this is going to say 316, but that's because it thinks it's a quantitative variable. I could make that categorical and just make it say 1 through 5. And actually, I think if I can actually do one last thing here on size, I can do a categorical variable like a procrastination level. Perfect. This is going to be a lot better. Okay, let's try this. So I've got procrastination levels from 1 through 5. Let's do 1. Let's give these people a 2, a 4. I'm just going to go up the line right here. 6. And you can kind of do whatever you want with this. And then for the ones that don't have one, I guess I'll just give them a 1 for now. All right, let's go. There we go. That looks good. I would have made them a little bigger personally, but the procrastination levels are going to look good here. I did have one person without data. Shoot. They must not have answered that one. But now you can see the procrastination levels of people, and oh man, look at those bad procrastinators down there. They were high attenders though, so it's not bad. But we got a high procrastinator there too. All right, so those are some of the basics for dot plots in Prism. It's a very good way to again add that fourth dimension to your data that otherwise can be really tough to showcase. And it's got some diversity in what you can show. One warning is that do be careful with very spread out data. Like gene expression, sometimes there's usually like one plot with like a huge number. That one will outdo the other ones. So if I needed to do that, so let's pretend here that I like just can't deal with the people that are 5s right here. I could technically say like, hey, anything beyond a certain value, or sorry, I need to do Need to do a percent. Let's say lab percent. So if I did need to say, hey, smallest and largest, I could say, hey, I'm only going to count certain things that like only go like a certain amount. So here, if I want to say I only need to see people that had an 80% or lower, technically, you can say you can display the max symbol size for anything over that 80% that I'm giving, or I could just get rid of it. And in that case, again, I kind of just did a blatant example there to show people that still had lower than 80% of lab scores. So you do have some capabilities in terms of customizing who's allowed on the plot, things like that. Because if you do get someone that is just like a massive number, it could blow up the scale in that case. So that tool that I just showed you is a way to customize and say like, hey, if you're too big or too small on the other end, you can get omitted or just called the max size or the smallest size. So you don't get one giant bubble amongst a bunch of tiny ones. So thanks so much for listening to this one, and I'll see you next time.